If we want to understand quantum mechanics, it's helpful to think in terms of events, for which we need an event device and a clock that records a list of times when there were events. An event device is a special type of state measurement device that has its output always near 0 or near 1. An event happens when the output changes from 0 to 1, and we record the time. If we have an event device on its own, events happen at what is called the dark rate. If we introduce a state preparation device and turn on the power, we record more events. If we move the event device, we record more or fewer events. Let's suppose we have one state preparation device, but now we have many event devices, so we have many event lists. If we put something in between, a double slit, the pattern of events changes to give an interference pattern that we can most easily see by adding up how many events there are in each list, though we can also consider more complicated statistics. If we move the slits or change their shapes, the pattern of events changes. We can describe and predict patterns of events using a quantum field. If we're using light, we use quantum optics. Let's look at a classic real experiment from 1998. This schematic is from Gregor Wies's PhD thesis in Vienna. There are 4 event devices, 2 here and 2 there, hundreds of meters apart, and a very special state preparation device that causes events to happen at the same time a lot. It's traditional to call the 2 ends of this experiment Alice and Bob. We can see that Alice and Bob each has a clock and a list of event times. Alice and Bob also have an adjustable polarizer each, which changes the patterns of events, and the way it is set at the time of each event is also recorded. About 1/20th of all Alice's events happen at the same time as an event recorded by Bob, within about 3 nanoseconds, about the time light takes to propagate 1 meter. When we look at those events, we find that when the polarizer is set approximately the same, we see few events at the same time. When they're set nearly 90 degrees apart, we see more events. The pattern we see here is what a violation of the Bell inequality looks like. Gregor Wies's experiment was especially significant at the time because he was able to change the polarizer settings fast enough to rule out more kinds of classical models. The problem is not that we can't think of a way for events to be caused by something, but that there are so many ways. We have no way to tell whether any of the ways we've thought of is even remotely right. We have weird superdeterminism, weird loopholes, weird faster-than-light stuff that we can't detect, or your weird idea here. We've not mentioned something. Sometimes event coincidences are very striking. At CERN we see almost lines of events. We can touch our event devices. But when we're thinking about quantum mechanics, try not to invent something that causes the event. More generally than events, we can talk about signals. Not all signals are constrained to be near one of 2 values with almost obvious transitions. We can record signals as often as we can, instead of recording event times. Quantum fields are an effective way to describe patterns as signals as well as events. An underappreciated way to understand quantum field theory is as a signal analysis formalism. A quantum field is like a classical field, such as electromagnetism, but it's more complicated because it's about possibilities when we use many different state measurement devices. It describes all the patterns that might happen and how likely each pattern is, instead of describing just one thing that happened or that we expect to happen in one experiment. Especially, a quantum field includes a new kind of noise called quantum fluctuations that affects all measurements. What we've been seeing is somewhat like the Copenhagen interpretation. There are experimenters, experiments, and the records we keep. Nothing else to see here. But the Copenhagen interpretation doesn't talk about events. We can avoid some troubles, even many, if we talk about quantum fields and lists of events and patterns, not about stuff that supposedly causes the events and patterns we see that isn't very useful.